Hello, hi, and welcome to our next video of CSIR net physics regarding the condensed matter physics. We were discussing about the condensed matter physics regarding condensed matter physics for last few days, and in the last video we actually have discussed up to the device theory. So today we are going to discuss something new about on condensed matter physics, and that topic for today is block theorem. And about this fundamental theorem of condensed matter physics that is basically very much important in describing many problems in condensed matter physics as well as in quantum mechanics also. It handles means many problems based on potential, well, based on different other problems. So today we are going to discuss that fundamental theorem, what the theorem tells about the quantum phenomena of any particle. What is the theorem, बेसिक स्टेटमेंट ऑफ द थ्योरम. सो आज हम ब्लॉक थ्योरम की जो फंडामेंटल बातें हैं, जो बेसिक उसका कॉन्सेप्ट है, वो हम देखने जाएंगे आज कि उसमें मतलब क्या ख़ास बात है, कैसे वो क्वांटम फेनोमेना को डील करते हैं किसी पार्टिकल की जो क्वांटम बिहेवियर शो करते हैं बेसिकली. तो let's start our today's topic, means on Bloch's theorem. And the theorem tells us that the potential at a point x and at x plus a are same, and the waveform is repeated at the points. So that means actually that a wave repeats itself at various point. After certain time period, the wave gets actually repeated itself frequently. So that is the basic statement of the theorem, basic concept of the theorem. And this theorem can be proved with the help of our means Schrodinger's theorem, the theorem that is Schrodinger's equation, that is the equation that is the what can I say, that discuss a lot about the quantum mechanics, the quantum behavior, that is Schrodinger's theorem. We'll learn about Schrodinger's theorem in a detailed way in quantum mechanics. So now that Schrodinger equation reads d2 psi dx2 plus 2m by a square into e minus bx into psi equal to 0. So this is the Schrodinger's equation, and the solution of this equation would be psi equal to e power plus minus I kx ukx. So the solution can be found from the solution of differential equation. We know how to uh, have the differential equation solved, this kind of differential equation solved using the techniques in mathematical physics. Using the techniques in differential equation in mathematical physics, we know that the solution of this kind of equation is psi equal to e power plus minus I kx ukx. So here, from here we can get the solution of the wave function. This is the wave function, this is nothing but the wave function. So if we put here instead of x plus a, then the waveform remains the same, the waveform does not change itself. So that's why we can say that at after a certain period, means here that I am saying that we are going to write x plus a instead of means x here, just like we are actually trying to write the wave function as psi equal to e power e power plus minus I k into x plus a into u k uk x plus a. uk x plus a. So just you see, the wave pattern is same, maybe the point is different, the coordinate is different, x and x plus a, but the pattern of the wave is same. The wave does not change its pattern, so that's why the wave is getting repeated itself after a certain period. So that's why according to the Bloch's theorem, and that is being verified by the Schrodinger's equation also, the solution of the Schrodinger's equation also, that the wave will be getting itself repeated after a certain period of coordinate. So that is the basic concept of the theorem, Bloch theorem. So we are actually means trying to verify itself from the Schrodinger's equation, and it is means verified from the Schrodinger's equation. So using the idea of this Bloch theorem, Kronig-Penney also discussed their own model regarding electron, that electron in a potential box means in a constant potential, uh, under the field of a constant potential, the wave of electron also gets repeated itself after a certain period, and that can also be proved in a range using the Schrodinger's equation. So the basic idea of Kronig-Penney model that illustrates the behavior of electrons in a periodic potential by assuming a relatively simple one-dimensional model of periodic potential as shown in figure, which shows the periodic potential energy of a valence electron in the x direction, means the electrons that those are in valence shell, how means the wave gets changed after certain period, or means certain coordinates, that is being actually discussed by Kronig-Penney model using the idea or using the concept of Bloch theorem. So that is the application of Bloch theorem. Bloch theorem can be verified using the Schrodinger's equation and can successfully used in Kronig means to describe the Kronig-Penney model. So यहाँ पे हमने देखा है कि ब्लॉक थ्योरम को हम श्रोडिंगर इक्वेशन को यूज़ करके, श्रोडिंगर इक्वेशन को इस्तेमाल करके प्रूव कर सकते हैं, उसको मतलब सही साबित कर सकते हैं, एंड उसको यूज़ करके, उसको इस्तेमाल करके Kronig-Penney ने भी अपना एक मॉडल बनाया, और जिस मॉडल पर वो वैलेंस शेल में रहते हुए, वैलेंस शेल में मतलब जो इलेक्ट्रॉन्स रहते हैं उसका जो वेव बिहेवियर है उसको भी डिस्क्राइब किया था। तो ब्लॉक थ्योरम का श्रोडिंगर्स इक्वेशन से वेरिफिकेशन भी हुआ है, उसको मतलब वो मतलब सही है, उसका साबित भी हमें मिला है श्रोडिंगर इक्वेशन से, एंड उसका सक्सेसफुल यूज़ भी हुआ है Kronig-Penney मॉडल में। तो ये था हमारा आज की डिस्कशन रिगार्डिंग ब्लॉक थ्योरम एंड Kronig-Penney मॉडल. Though it is not means that much important for CSIR net, but few questions came up in few gate exams regarding Kronig-Penney model. So that's why means in today's video we have discussed about our Kronig-Penney model. So in the next video we shall actually discuss about something new of the condensed matter physics. So till that means stay tuned with our channel, and like, share, and keep watching, keep learning. Thank you all for watching the video. Good night.